All right, so we are pretty much going to hit two sections today. This is 6.2 and 6.3, which is over medians and altitudes and points of concurrency. So by definition, a point of concurrency is when you have three or more lines and they all intersect in the same place. This is called a point of concurrency. And since we have altitudes, then that means if we have a triangle, then there are three altitudes because there are three sides. There are three medians because there are three corners. So in a triangle, there's going to be three of every single special segment, and they each have their very own point of concurrency. So let's look at the circumcenter. The circumcenter is formed by all of your perpendicular bisectors. The circumcenter is equidistant, meaning it's the same distance from all three vertices or corners. And the circumcenter is the center of the circle that the triangle can be inscribed within. In other words, there's a circle on the outside. So and the circumcenter can be inside or outside of the circle, just depending on what type of circle it is, or sorry, what type of triangle it is. So for example, a perpendicular bisector means I need a perpendicular line at the midpoint. So what I'm going to do here is I'm just going to kind of eyeball it, and I'm going to draw my midpoint here, and then I'm going to draw another midpoint over here. So this piece is equal to this piece, and this one is equal to this one. I don't know if they're the same, so I got to label them different. Now what you're going to do is, I know I get a little advantage here, so you go to the midpoint and you draw a line that is perpendicular to that midpoint. So this is perpendicular right here. Now I'm going to go to this one over here, and I'm going to draw a line that is perpendicular to that midpoint. So let me get this where it's right in center. So now this is about, and I know it's not exact, but it's close enough. So where these two intersect, this is called the circumcenter. Now what's really cool about the circumcenter is, and I'm going to do this in a dotted line that is, we'll do purple, no, we will do green. Okay, so if you go to this corner right here, if you were to draw, or sorry, to the point and you drew to each one of the corners, all three of these lines are the same size. So if you think about it, like what I always think about is, you know, sometimes when you're driving and you see a store or something that's being built, and you're like, wow, that seems like a weird place. So basically, let's say that there's a store being built and there's these three neighborhoods. Well, if I build my store right here, I'm the same distance to all three of these neighborhoods. So that means I can triple my clientele or my customers by putting a store that's the same distance from all of them. And then of course there'll be other neighborhoods around as well. So all of these dotted lines are going to be the same length. Okay, so that is what's special about perpendicular bisectors and the circumcenter. So remember, perpendicular bisectors start at the midpoint of a side and they move perpendicular to that side. So always find your midpoint and then draw a line that is perpendicular, and that will be your perpendicular bisector. All right, the next one. This is our end center. The end center is formed by your angle bisectors. It's equidistant to the sides. It's the center of the circle that can be drawn on the inside of the circle, and it will always be inside the triangle. Okay, so all right, so let me go back here for just a second. Whenever I was talking about the circle, so for example, if I were to come here, and now I'm going to be a little bit off because I did eyeball this, so it's not exact, but you can kind of get an idea here. If I were to draw a circle, it's pretty close, so I was pretty close. So the reason these dotted lines are the same is because they're the radius to that circle. So each one of my corners are on the edge of the circle because each one of these dotted lines represent a radius, and you know the radius in any circle is always going to be the same. In this case, so let's go ahead and draw our angle bisectors. So you're gonna, obviously you're gonna eyeball it a little bit. So go to your corner, and that looks about right. And of course, you're doing this on your paper, so that looks about right. So now this point right here, this is my end center, okay? And the end center is the same distance to all of the sides. So now if I take, and I will make them, oops. So now if I go here, well, dadgummit, I need this to be red. All right, so now if I go here, I'm going to draw a perpendicular line to each side. So from here, if I draw a perpendicular line, and sometimes they're going to be close to the actual line that you used. So if you draw a perpendicular line, you will see that these are all perpendicular because there's a circle on the inside this time. And again, I'm a little bit off, but still pretty close. So if you draw a circle on the inside, those red lines, those are the radius to the circle. So these are all going to be the same length as each other. Okay, so reminder, angle bisectors, they cut the angle in half. So you're kind of looking at these tick marks here where things are cut in half. And obviously there's a third one, but it's automatically going to go through here. All right, next we have a centroid. The centroid is formed by your medians. Okay, sorry, I had to take a phone call. So centroid. The centroid is the intersection of all your medians. So remember, your median connects the midpoint and the corner. It is the center of gravity. So when you draw all your medians and you get the centroid location, you could actually balance this triangle on the tip of your pencil if it is exactly where it's supposed to be, because that's the balancing point for the triangle. So this one will always be on the inside of the triangle. So let's do a quick, all right, so I'm gonna, since centroid is formed by my medians, that means I need midpoints. So just kind of eyeballing it here, that looks like it's about close enough. And I need to get my line style back. So there's that median there, or that midpoint there, and then I'll try this one here. So that looks pretty close. So now I'm going to take and draw my lines. So the median, go to the midpoint and then draw straight over to the corner. So midpoint to corner. So remember, a perpendicular bisector is from the midpoint, but it's perpendicular. So a median does not have to be perpendicular. So now this is the centroid. Okay, this is the centroid. And this is the center of gravity. The cool thing too is this distance here, from here to here, and we'll get back more into this in just a second, but this distance is 2/3, and then this distance is 1/3 of the whole thing. Okay, so like I said, we'll get more into that in a minute, but for now, that is your center of gravity, and it is 2/3 of your distance. All right, and then our last one is our orthocenter. The orthocenter is formed by all your altitudes. So if you draw all your perpendicular lines, it can be inside, outside, or on the triangle. It's going to be inside when it's acute. It's going to be outside when it's obtuse. And it's going to be on the triangle when it's a right triangle. And it will always be at the right angle. Okay, so if you had a right triangle, the orthocenter is at the right angle. The circumcenter in a right triangle is the midpoint of the hypotenuse, so that one gets kind of tricky. But what we're going to do here is I'm going to go to the corner, and I'm just going to draw a line straight down, not to a point, just straight down, because that is perpendicular. And then I'm going to draw another one. So coming over here to this corner, drawing a line that is perpendicular. Make sure you put your right angle marks. This is your orthocenter. And remember, altitudes, they're the tallest part of each side. And it has to be perpendicular to the opposite side. So if I were to draw the third one in here, so if you went to your corner and you drew a line that was perpendicular, if you'll notice, even eyeballing it, I still got pretty stinking close. Okay. All right. So now let's do some math problems with this. So first thing you have to remember, perpendicular bisectors have circumcenters, angle bisectors have incenters, medians have centroids, and altitudes have orthocenters. So a way you could remember is precious cats are inside, mean cats are outside. Might not necessarily be true statement, but it is an acronym, a way to create an acronym to help you remember the ones that go together. So the precious cats are inside. This is going to be your bisectors, and mean cats are outside are going to be your medians and your altitudes. So just a little quirky way you might come up with your own. All right, so in each figure below, tell what point of concurrency is shown and what construction form that point. So for example, I'm at the corner and I look down and I see that it is just perpendicular. So I know that this is going to be an altitude. So since this is an altitude, I know that the point where they intersect is going to be my orthocenter. So we'll just slide this over here. Now this one here, remember the whole point of the warm-up the last time is looking at these tick marks. Your eyes need to be able to recognize what they see. So these 3 tick marks mean this is a midpoint. These tick marks mean this is a midpoint. These tick marks mean this is a midpoint. So I have the corner to the midpoint. That means this is a central, this is a median, and this point right here is going to be my centroid. This is the one where this is 2/3 and this is 1/3. All right, so let's look at the last 2. Well, right away, if they have angle marks, that's automatically going to be an angle bisector. So this is an angle bisector. This is also an angle bisector, and this is also. So this is going to be an incenter because angle bisectors create incenters. So let's move this one, which means now this one over here, according to the tick marks, if those are equal, then that's a midpoint. I am perpendicular at the midpoint, therefore this is a perpendicular bisector, and the point of concurrency, or the point where they meet, this is your circumcenter. Do not forget the circumcenter. This is so super important. The circumcenter is equidistant to, oh, that is a really crooked line. This distance, if I go to my corners and I drive to the circumcenter, those distances are all the same because that's where I'm going to build my store. All right, so the special properties of centroids. So when I was telling you that it's 2/3 of the way. So I want you to think about 2/3 of the whole thing, okay? So the distance from the vertex to the centroid, so the longer piece, is 2/3 of the total, okay? And then the distance, the shorter distance, is 1/3 of the total, okay? So let's look at this one right here. So this whole thing right here is 30, okay? So if I did 2/3 of 30, 2 times 30 is 60. 60 divided by 3 is 20, which is why this is 20. Does that make sense? So, and then of course, if this is 20, if the whole thing is 30, then obviously that's going to be 10. So what about this one? So the rule is that your, let's see, the top part, so the top part is 2/3 of the whole thing. The whole thing would be x plus 4, which this is super crazy. So we're not going to, so the top part, we'll call that x. So if we wanted to solve that, we would go through and solve that, but that's a pretty crazy mess right there. So think about it. If this is 2/3 and this is 1/3, the easiest way, notice this is 10, double it, you get 20. So if this is 4, double it, you get 8. So that means the whole thing is 12. So the top part is 2/3, the bottom part is 1/3. And I know you hate fractions. The whole thing, or the bottom part, is half of the top part, however you want to think about it. So here, if this is 2, if you double, it's going to be 4. 2 plus 4 is 6. Part plus part is whole. 3 plus 6 is 9. Notice that if I double the 3, I get 6. Now what about this one? Okay, so what is 2/3 of 12? So what is the longer part? What is this part, the longer? So 2 times 12 is 24. 24 divided by 3 is 8. So that makes this part 8. Well, if this part's 8, then the smaller part is half of that. It's 4. So that's pretty much how the 2/3 is going to work. Obviously, you're going to have some algebra problems to do with that, but the main thing is the top part, or the bigger part, is 2/3 of the whole thing. The bottom, or the smaller part, is 1/3 of the whole median. And then the bottom also is half of the top. So there's multiple ways to kind of go about finding the numbers that you need. So we'll do some more practice later, and I will see you guys later. Bye.